Hi there, Mr. Holcomb here with another episode of The Math Behind the Module. This is Lesson 8, Drawing Polygons in the Coordinate Plane. Okay, so this first classwork example shows a coordinate plane. X-axis is labeled, Y-axis is labeled, and number 1 says plot and connect the points A32, B37, and C82. Name the shape and determine the area of this polygon. So if I'm going to plot A, I'm going to go to the right 3, 1, 2, 3, up 2, 1, 2, and put a dot here. I don't know where the rest of these are, so I'll wait. So there's A. B is 3, 7. So over 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7 is here. This is B. And C is 8, 2. 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, and that is right there. So I will call this A, and I'll put the point 3, 2. I'll call this B, and I'll put the point 3, 7, and this is C. This is the point C, and I'll call that 8, 2. So the first thing I do when I'm graphing something is plot the points and label them. A, B, C, and the values of the coordinate. And now we want to draw a straight line, so I'm going to get my ruler. Okay, bring that down. Always should be neat when we're doing these and precise. So there is my line segment AC. Need to rotate this 90 degrees, move this over. This is line segment AB, and then this is the toughest part on the computer anyway, is rotating this to line up with my points. And right about there. So there it is. There's my diagram. It says name the shape. It is a triangle. And more specifically, it is a right triangle. Since I said that, I will label it. This is a 90-degree angle right here, so it's a right triangle. Because this line is horizontal. And how do I know that? The Y values are both 2. And this is a vertical line, which I know that because the X values are both 3. So we've named the shape, and now I want to know the area of the polygon. So I'd write A equals base times height divided by 2, or 1/2 base times height. So step 1, write the formula. Step 2, substitute in the given. So the length of this side is the distance from 8 and 3, which is 5. Times the height, which is the difference between 7 and 2, which is 5, all divided by 2. So the area equals 25 divided by 2, which is 12 1/2 units squared. Now, I should have said unit here and units here and units squared here. Okay, so my answer is 12 1/2 square units. Number 2, plot and connect the points E equals -8, 8, F of -2, 5, and G -7, 2. Then give the best name for the polygon and determine its area. So let me pause the video. I will copy the graph here so we can work on it. Okay, so here we have the graph that we're going to work with. A little bit smaller, but that's okay. And E is -8, 8. So I go 1, 2, 3, 4, 5, 6, 7, 8, up 8, which is right here. The reason I know that's a 10 by 10 grid, so 8 is 2 less than 10. And then -2, 5. Over 2, up 1, 2, 3, 4, 5 is here. And finally, -7 is here and up 2. Okay, so then I get my ruler. And bear with me, I rotate. pretty good right there. Draw my line segment. Slide this around here. Right about there. And finally rotate it around the other way. And draw that segment. Okay. Okay, and I don't see any right angles there. This doesn't look like a right angle. It's close, but it's smaller than a right angle. So it says give the best name for the polygon. So I wouldn't just say a triangle. I would say an acute triangle. And determine its area. Well, in order to determine its area, I need to determine its altitude and its base. So I would draw a line segment here that would extend over. So the base distance is this distance, and the height distance, make that 90 degrees. My height is right here. So if I rotated that a little bit, that would be my area, or my triangle, if the base was lying flat and so forth. Okay, so I didn't want to take all the time drawing these, so I paused the video, but I draw a square around this, and then I know the area of a square is side squared, and if I count, it's 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. Okay, so it's the area of the square is 6 times 6, which equals 36 units squared. Okay, so that's the whole thing. That's 36. Now I have a right triangle here that goes from here to here, over and back up. So this is 6. This is 1. So the area of triangle 1 equals, I'll call this triangle 1, base times height divided by 2, which equals 1 times 6 divided by 2. So the area of 1 is 6 times 1 is 6, divided by 2 is 3 units squared. Then I will do triangle 2. I'll use purple this time. Let's call this triangle 2 here. This distance is 6. This distance is 3. So the area equals base times height. Area equals the base of 6 times the height of 3 divided by 2. I forgot over 2. Let's make that neater. Divided by 2. So the formula is base times height divided by 2. So that's area of the base, 6 times 3 divided by 2. I'm going to reduce first here. 6 divided by 2 is 3, and 3 times 3 is 9 units. So that's triangle 2. Now I'm going to calculate the area of triangle 3, which is right here, and that has a distance of 1, 2, 3. That's 3. And this has a distance of 1, 2, 3, 4, 5. So the area of triangle 3 is base times height divided by 2, which equals 5 times 3 divided by 2, which equals 15 divided by 2, or 7 1/2 units. Okay, so I know the area of the whole thing, and I know the area of the 3 triangles outside this green triangle. So I need to take the area of the red square and subtract the area of the triangle 1, 2, and 3. So the area of the triangle I'm looking for equals 36 minus the sum of the other 3 triangles, which is 3 plus 9 plus 7 1/2. So the area of the triangle is 36 minus area of the triangle equals 36 minus 9 plus 3 is 12, 19 and 1/2. So the area of the triangle equals 16 and a half units squared. 16 and 1/2 units squared. Okay. Okay, so here's number 3. It says plot and connect the following points. So the first thing I'm going to do is plot these. I'll use red this time. K is -9, -7. So left 9 and down 7, which is right here. And then left 4, 1, 2, 3, 4, down 2 is L. M is -1, -5, which is right here. And N is -5, -5. Give the best name for the polygon and determine its area. Okay, so if I label these points, this is K, this is L, -4, -2, M is -1, -5, and N was the last one we plotted. And whenever we plot points, we have to draw our line segments from the named letters in their order. So what I mean is K came first, L second, so I'm going to draw them in as from K to L. Try to line up my ruler. So K to L is right there. I'm off a little, but let's try that again. Just need to rotate this up just a little, that's better. So K to L is KL, there's KL. And then I'm going to go from L to M. Okay, and then M to N. And then finally, N back to K. And there's our shape. Okay, they did not ask us to name this, that's good. It is a polygon, let's just call it that. It is a four-sided figure, but let's just call it a polygon. It says plot and connect the following points for the polygon and determine the area. All right, now in order to find the area of this, I can break it up into different triangles, and the best way to do it would be as if we identify this line here and break it up into these two different triangles. And we need to determine the distance here. So N has a X value of -5, that's -5, and this has a value of, it looks like -7, so that would be a distance of 2. I'm just going to label that a 2. This piece here, this is a triangle of distance 1, 2, 3, 4, 5, 6. That is a length of 6 all the way across here. And then I need to know this height, which is right here. And that is a distance of 1, 2, 3. So this is 3. So the area of this triangle up here, let's call it triangle 1. Okay, this is triangle 1. The area is base times height divided by 2. And the base was this 6, 1, 2, 3, 4, 5, 6, times the height, 1, 2, 3, divided by 2. And I'm going to reduce the 6 and the 2 and get 3. So the area is 9 units squared. Okay, so that's this triangle up here. Now I have to find the area of this red triangle here. And in order to do that, I'm going to put a box around it and subtract. So this is a distance of 2. Actually, that could be my base. And if I draw a vertical line to here, and over to here, that could be my height. So the base of 2. So the area of triangle 2 is base times height divided by 2, which equals a base of 2 times a height of 2 divided by 2. Well, that's going to cancel one of my 2's, and that area is 2 units squared. So the area total is 9 units squared plus the 2 units. Ran off my board there. So the area total is 11 units squared. Okay, now we're on to number 5. It says plot and connect the following points. P, 1, negative 4. So that's P right here. Q, 5, negative 2. So I'm going to connect these as I go so it's less confusing. Okay, so there's line segment PQ. I may have to move these, but so far so good. Okay, and the next one is R, which is 9, negative 4. So here's 9, 1, 2, 3, 4 is right here. And then I will draw the segment to those, between those, from Q to here. Okay, so there's the point QR. This is R. And now we want RS. S is 7, negative 8. So 10, 9, 8, 7, negative 8 is here. So here's S. So to draw that, I need to rotate my ruler. Okay, there's RS. And T is 3, negative 8. 1, 2, 3. Here is T. And then close it out. Okay, so there is our shape. Give you the best name for the polygon. Well, it's 1, 2, 3, 4, 5-sided. So I'll call that a pentagon. And we need to determine its area. Okay, so I'm seeing a few things here. If I rotate my ruler vertically and draw a line here, okay, that's a triangle. And then I can draw a line here. That is another triangle over here. And then when I rotate this till it gets down to 0 degrees or 180 degrees, and I move it up to those 2 line segments that I just created, then that's that there. So I just created a rectangle and 3 triangles. Okay, there's more than one way to do this. This way here, I would also have to draw altitudes. Okay, so there's better ways to do these. We could also do it this way. I can find the area of this rectangle plus the area of the 3 triangles, but in order to do that, I need to know the altitude here, the altitude here, which is fine, and the altitude here. So I'll do this way. There is other ways, but let's just leave this as is. So the area of the rectangle equals base times height. So the area of the rectangle equals a base of 1, 2, 3, 4. This is a distance of 4. 1, 2, 3, 4, 5. This is 5. So it's base 4 times height 5. So the area of the rectangle is 20 units squared. Okay, now we're going to do the area of the red triangle, and I will just outline this in red. I won't worry about the ruler at this point. I'll just try to do it as neat as I can. This will be the red triangle. We know the height is 2 because that's vertical to, or that's perpendicular to the vertical line is what I meant to say. So this length is 1, 2, 3, 4, 5. That's 5. And the height here is 2. So the area of red triangle is base times height divided by 2, which equals the base, which is 5, times the height, which is 2, divided by 2. Those 2's cancel, so the area of the red triangle equals 5 units squared. Okay, now we're going to find the area of this green triangle here. And that is 1, 2, 3, 4. This is 4 units, and the height is 1. So that is 1 unit. So the area of the green triangle equals base times height divided by 2. So the area of this triangle is the base, which is 4, times the height, which is 1, divided by 2. So the area of this triangle is, those cancel a 2, 2 times 1 is 2 units squared. And then finally, the last triangle here is this triangle here. The altitude or height is right here, which is 2. And the triangle's base is this 5 right here. So the area of the blue triangle is base times height over 2. So the area of this triangle is 5 times 2 divided by 2. Cancel the 2's, so it's 5 units squared. So if I want this total area, so the area total equals the area of the rectangle plus the area of the red triangle plus the area of the green triangle plus the area of the blue triangle. So it's 20 plus 5 plus 2 plus 5 units squared. So the area total is 32 units squared. Okay, number 5. Okay, number 5. 2 of the coordinates of a rectangle are 3, 7. So if I go over 1, 2, 3, and up 7, which is right here, there's 3, 7, that's A. And B is 3, 2 over 1, 2, 3, up 1, 2, that's B. Okay, it says it is a rectangle. So this is a line segment, AB. So I can draw this side up right now. Okay, so there's side AB. And it says the rectangle has an area of 30 square units. Well, what's the length of this? Because that's its height. 1, 2, 3, 4, 5. So this is 5 units. I'll just write the number 5. And they told us the area of the rectangle has an area of 30 square units. Give the possible locations of the other 2 vertices by identifying the coordinates. Use the coordinate plane to draw and check your answer. So area of a rectangle is base times height. And I'm always going to emphasize using the formulas so you know where to substitute things in. We were told the area is 30 square units. That's my A. So I'm going to put 30 units squared in place of the A. I don't know my base. There's nothing drawn yet, but I know my height is 5. So my base times 5 units. Okay? So in order to get B by itself, I want to divide by that 5 units to get B alone. Okay, we're isolating the variable, so the 5 units cancel. So if I divide 5 units on one side, I have to do it on the other. And the units will cancel one of the units up here, and the 30 and the 5 will become 6. So in other words, B equals 6 units. That is my base. So now I'm going to draw the base. I will use green, so I want to go over 6 units, 1, 2, 3, 4, 5, 6 right here, and over 6 from the A would put me right here. So there is one possible solution. rotate this to 90, bring it over. Okay, there's the top, and there's the bottom. Okay, so there is a triangle that is 30 square units. This is a distance of 6, this is a distance of 5, 6 times 5 is 30. I could take the time and count. There's 6 squares, 12, 18, 24, 30. Okay, but there is also another way to do this. AB was just my starting point. It did not say what direction I had to go. So in order to get a rectangle of 6 units, base with a 5 unit height, to get those 30 units, I could go left 6. 1, 2, 3, 4, 5, 6. I could have put my point here and drawn a rectangle over here instead. And so there are my two possible solutions, the black rectangle or the green one that share that purple side. Okay, exercise. For exercise 1 and 2, plot the points, name the shape, and determine the area of the shape. Write an expression that could be used to determine the area of the figure. Explain how each part of the expression corresponds to the situation. Okay, so here's number 1. First, let's plot the points. What color can we use here? Let's use red. A is 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Here's A. B is 8, 6. So over to 8 and up 6. So B is right here. And C is 10, 2, which is here. And D is 8, negative 3, which is here. E is 5, negative 3. There's E, and F is 2, 2. Okay, so I did touch this thing here and get rid of that. Okay, so there is my diagram. Then I'm going to connect the dots. This is segment AB. And let me pause the video while I'm drawing this so I'm not taking up your time. Okay, so there it is. A, B, C, D, E, F. It is a 6-sided figure. So that's a hexagon. Okay, so it says for exercise 1 and 2, plot the points. Done. Name the shape. Hexagon. Done. And determine the area of the shape. So now we need to find the area. Well, a hexagon, I guess I could do a triangle here, a triangle here, this triangle over here, and this triangle over here with a rectangle in between. But then this is off, so that's not going to work. That's not good. So we need to try to come up with a better way than that. So let's see. Okay. How about I draw a line down here? So I have a rectangle here, I have a triangle here, and then there's this vertex here that I could come over to here, but I don't want this point, this line segment here. I'm going to get that out of the way and redraw this. So we have bit of a problem right here. So there's a rectangle. Now I have a triangle here. I have a triangle here, a rectangle here, a rectangle here, and a triangle there. So there are 1, 2, 3 triangles and 2 rectangles. So we will calculate the areas of all of these and add them up. Okay, so I'm going to start with the easier one, this small little rectangle here. That's a base of 1 and a height of 4. So the area equals base times height. So the area equals 1 times 4. So the area equals 4 units squared. And then I will focus on this triangle here. And the height is 2. And the base is this 4. So the area of a triangle is the base times height divided by 2. So the area of this triangle is the base, which is 2, times the height, which is 4, divided by 2. These 2's cancel, so the area is 4 units squared. The area of this triangle down here has a height of 1, 2, 3. So now this whole thing is 3. So let me just move this 2 inside here. Well, it doesn't move, so here's what I'll do. I'll move this over here, and just to get the values out of the way. All right, so now this height here is 3, and this is 1, 2, 3, 4, 5. So this is 5. So I'd say the area equals base times height divided by 2. So the area equals the base of 3 times the height of 5 divided by 2. So the area equals 15 divided by 2, or 7.5 units squared. So there's these 3 pieces right here. And I continue on with this fashion, and the area of the rectangle now, which is here, this rectangular piece here, has a base of 3 and a height of 3, 4, 5, 6, 7, 8, 9. So the area of a rectangle is base times height. So the area of this rectangle is 3 times 9, or 27 units squared. Finally, the last piece is this triangle right here, over here and over here. The height is right here, and that is a distance of 2. The height here is 9, or the base is 9. So the area of a triangle is the base times height divided by 2. And the area of this triangle's base is 9 times the height, 2, divided by 2. And the 2's cancel. So the area of the red triangle is 9 units squared. Finally, I'm going to do the total area. The area total equals 4 units squared. And I'm not going to write units squared every time, so I'll put these values in parentheses, put units squared at the end. 4 units squared plus 4 units squared plus 7.5 units squared plus 27 units squared plus 9 units squared. So the area total equals 4 plus 4 is 8, 15.5 plus 27 is 42.5 plus 9 is 51.5 units squared. Okay, so now we're on to problem number 2. And I'm going to first graph the points. Negative 9 is right here. On the x-axis, we start at 0, left 9, up 6 is right here, and that is x. Negative 2, left 2, negative 1 is here, and that is y. And c is negative 8, negative 7, and that is c. So let me get my ruler. And I will rotate it, and we'll get these drawn. So let me pause the video so you aren't waiting. Okay, so here's our triangle. Now whenever we're looking for area of a triangle, we need to have either the height or the base horizontal or vertical, and none of these lines are either horizontal nor vertical. This one has a steep slope that moved over 1 unit, so none of these are horizontal or vertical. So the only option we have in this situation is drawing a box around the whole thing. I will do that, and I'll come back with that. Okay, so here's the box around the outside. So I need to find the area of the whole thing. So let's do that first. The area of the rectangle equals base times height. The area of this rectangle, its base is 1, 2, 3, 4, 5, 6, 7. This is a distance of 7. And the height is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 7 and 6 is 13. So the sides are 13. So it's a 7 by 13 rectangle. 7 times 13. So the area of the rectangle is 91 units squared. Okay, so now we know the entire area. Now I have to find the area of triangle 1, triangle 2, and triangle 3, and subtract them. So triangle 1 has a base of 1 and a height of 13. So the area of a triangle is base times height divided by 2, and this base is 1, height of 13 divided by 2. So the area is 13 divided by 2, or 6.5 units squared. The area of triangle number 2 has, this is a 7, distance of 7 here. From here down to here was 6. 1, 2, 3, 4, 5, 6. So the area of a triangle is base times height divided by 2. The area of this triangle is a base of 7 times a height of 6 divided by 2. The 6 and the 2 will reduce to 3, so the area is 21 units squared. That is the green area. Now I'll do number 3, triangle number 3. The area of the triangle is base times height divided by 2. The area is, now my base is not all 7 of these. I have to subtract 1 because I'm only going to here. So this distance here is 6 times the height, 1, 2, 3, 4, 5, 6. Okay, so the height is 6 divided by 2. So the area equals, these will reduce 18 units squared. So I found the area of the triangle here, and the triangle here, and I know the whole thing. So the red triangle in the middle is going to be the total minus these other 3. Okay, so I'll use red here because that's, well, I'll use purple. I haven't used that yet. So the area total equals the whole area, 91, minus the sum of the other 3 triangles that are outside this triangle here, which would be 6.5 plus 21 plus 18 units squared. So the area total equals 91 minus, and 18 plus 21 is 39, plus 6 is 45 and a half. So it's 45.5 units squared. So the area total is 0.5. And if I put a 91 here and I have to borrow and make that a 10, that's 5. So I'd have to borrow again to get that 8. That's a 545. Okay, 45.5 units squared. Okay, now I got thinking about this, and I'm looking at this 6 and this 6 and this 13. I counted incorrectly. This distance here is 6, but this vertex is down here. So I have made one minor mistake in my calculations, and it's always good to check your work after, like I just did. That is also a 7. Let me use the right color. This is also 7 over here. So I need to fix this here. It's not 7 times 6 divided by 2. It is 7 times 7 divided by 2, which equals 49 divided by 2, which is 24.5 units squared. Okay, so now I need to fix the other portion, which is right here. So I'll just move this down and rewrite it. So the 6.5 was correct, but the 21 was incorrect. It's actually 24.5, plus the 18 was correct, units squared. Okay, so I'm just going to erase this piece. All right, so now that I've done that, my calculation is now going to be different here. It is now going to be 91 minus 24 and 6 is 31 plus 18 is 49. And 91 minus 49 is 42. Okay. So there I just caught that error after I was done, but it's always a good idea to check your work and see if everything makes sense. So it is 42 units squared. Okay, number 3. A rectangle with vertices located at these 3 locations of 32 square units, determine the location of, it says determine the location of the other 2 vertices. So let me bring in a grid, I'll pause the video. Okay, so this rectangle has a vertex of -3, -1, -2, -3, and up 4. 1, 2, 3, 4 is right here. 5 4s, 1, 2, 3, 4, 5, up 1, 2, 3, 4 is right here. And it has an area of 32 square units. So the first thing I want to do is determine how long this is. So I bring in my ruler and I draw a line segment here. And that is a distance of 3, and this is a distance of 5. So 5 plus 3 is 8. I also could have looked here. Okay, absolute value of 3 plus the absolute value of 5 is 8. So if I have an area equal to base times height, because it's a rectangle, and I know the area is 32 units squared, and I know my base is 8 units times the height, then I divide by 8 units to find the height. The 8's cancel, the units cancel, leaving h equal to, the units cancel with one of these units, and 32 divided by 8 is 4. So I just need to draw a rectangle of height 4. So if I go down 1, 2, 3, 4, I'm actually on the x-axis here and here. And in order to finish this, I just bring this up. Let me use red for the whole thing. Rotate to 90 degrees and draw these sides. And there's my rectangle of area 32. So this is actually units. Okay, so it says determine the location of the other 2 vertices. So I haven't answered the question yet. The other 2 vertices are -3, 0 and 5, 0. Okay, I also could have gone up. Instead of going down 4, I could have gone 1, 2, 3, 4 here and over here, and these 2 points are -3, 8, and this one is 5, 8. So those are the 2 possible solutions, right here and right here. Okay, last question. A triangle with vertices located at -2, -3, possible locations of the other. So I'm just going to get this stuff all out of the way, and we're just going to use this grid again here. All right, so I need to move this, I'm covering some of the wording. So I'll move this right here. It says a triangle with vertices located at -2, -3, which is here, and 3, -3, which is right here, has an area of 20 square units. Okay, so we're talking about a triangle, and we're talking about area. So I'm going to write the formula. Area equals base times height divided by 2. We know the area is 20 units squared, and that equals the base, which is 1, 2, 3, 4, 5, h divided by 2. And all I have to do is solve for h. Multiply both sides by 2, and that will give me 40 units squared equals 5h. That's actually 5 units h, and I need to write that with what's going to happen next. 5 units times h To solve that, I divide by 5 units and divide this by 5 units. And the 5 units cancel, and I get h equals, this units will cancel with one of the units, and 40 divided by 5 is 8 units. So the height is 8 units up, so I need to draw a triangle with a height of 8 units, and there are many, many, many answers to this. It's actually infinitely, I believe. And all I've got to do is go up 1, 2, 3, 4, 5, 6, 7, 8. So I know my height has to be, the vertex has to be on this line right here somewhere in space. And when I draw, it doesn't matter if I put it here, or if I put it here, or if I put it over here. When I connect these dots, as I'm going to do now, just give me a moment. It's very important to be precise. Okay, so there is that one. And now I'm going to rotate this like so. Then there is a triangle that is 20 square units. And if I move this dot over here or over here, the height has not changed, the base has not changed. No matter where I put this vertex, that would be a solution to this problem. So as long as you have an answer that gives you the height of 8, so I need to be up on the 5, so my y needs to be 5. So any number x comma 5, or I also could have gone below 8 units, 1, 2, 3, 4, 5, 6, 7, 8. I'm off the grid, but I could have done any x value comma negative 11. And that would have given me an area of a triangle of 20 square units. That is the end of lesson 8. Go do your problem set, and oh, by the way, smash the like.